Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Doug Szajda.
Paulie Perrone, how you doing?
I'm good. I know it's not Zaza, but it's Szajda. Here's your last name, Szajda. But
it is Szajda.
I'm sorry, I call you Doug Szajda because of a mutual friend of ours referred to you that when he was watching, I guess, The Godfather 3 years ago.
Mm-hmm. And so yeah, Szajda is close enough to Zaza, so I became Doug Szajda, and then shortened to DZ. But even though I haven't seen that particular friend in years, I still sign my emails DZ here, even as chair of the department, and no one says anything.
That's probably very confusing, yeah.
Yeah, no, they know it's me, and yeah, habit.
Well, we've known each other for 30 some years, it seems, at least, because I know you have a long history with many degrees. What do you have, like 25 or 26 degrees or something like that?
If you give me a calculator, I can start counting them up.
Yeah.
But actually, friends here used to say that I should write my own guide to East Coast colleges because I had been to so many. But yeah, my wife and I are like two of the most overeducated people that you'd want to know. So I think I have a bachelor's degree in math, a master's in math, a PhD in math, a master's in CS. I did a postdoc in CS, and I've been teaching computer science and math for almost 30 years now at the university level.
I know, so. It was always fascinating because I knew you as like the math guy, right? Math has come back and become something important for, well, it's always been important for computer science, but it's very much leveraged nowadays with neural networks and probabilistic theories and all of that, structure for computing, like gradient descent algorithms and all of these things that just make up really the foundation of neural networks and deep learning, which you're now, I know, into in a different capacity, and cybersecurity. So tell me a little bit about where your focus is now with respect to, I know you made this jump from sort of strict math to computer science and cybersecurity and how that all relates.
Right. So I made that jump about 25 years ago. I like math, and as you said, it's a tool that's really useful in cybersecurity and in machine learning. And I happen to think, and many people do, that machine learning is really just applied statistics. But I made that jump because for me, I really wanted to see. I was doing pure math, and I really wanted to see my math used places. If I was going to do math, if I was going to solve hard problems, I wanted to see it make a difference outside of just an academic consideration of a particular mathematical object that might or might not be useful. And so these days, I focus actually on the security of automated voice processing systems. But for years, I have been a security specialist. I'm the only one that's taught the security course at Richmond. That will change this spring. We have a new faculty member who does security, and I have passed the mantle. But I also, you can't really, I did what I would call straight security for years. And now you can't really do almost anything in CS without touching on machine learning. And so it evolved to adversarial machine learning. And the stuff I look at, like, for example, the security of Alexa or the security of Siri, this has become what I focus on these days, and aspects of that.
Interesting. So what is adversarial machine learning? Like what is that exactly?
So yeah, it's an interesting, in computer science.
It sounds menacing.
Yeah, it does sound menacing. So when I say this to people, sometimes they're like, "So you fight machine learning?" That's exactly what it is. Come at me. No, it's really people come up with these examples that intentionally fool machine learning models. So, as an example, I might have a very accurate image processor, and so an image processing model, and I tweak a couple of pixels in such a way that you wouldn't notice the difference. I mean, any human looking at it wouldn't see any difference at all, but the machine learning model is all of a sudden fooled. So it thinks it was a picture of a school bus, and now it thinks it's a picture of an orange. And really, when you see these pictures, they are humans can't distinguish between the two. They just looks like a school bus to me.
Hmm.
And not only can you fool the model into thinking that it's getting something wrong, but you can actually determine what you want it to think it is. So if there are, for example, 40 pictures, you can tweak the model in such a way, or tweak the image in such a way that the model thinks it's whatever you want it to be. Now, of course, you're going to tweak it different ways, but I want it to think that the school bus is an orange. I want it to think the school bus is a dog, etc. And related to some of the stuff that you work on, um, and this happens often in this space where a researcher comes up with something and then someone says, well, that would never work in the real world. So some researchers came up with a way that you could tweak a stop sign. It was an image of a stop sign, and you could make the model think that it was a speed limit 45-mile-an-hour sign. And the first response was, well, that's just because that's an image. You could never do that in a real world. And what they showed was, well, actually we can. And they went out, they put some tape on a stop sign, and they had a system come down, and it was like, oh, speed limit 45 miles an hour. So this is adversarial machine learning, and maybe something we'll talk about later is that I'm one of these people that believes that fundamentally we're doing machine learning wrong, um, because of this kind of thing.
Yeah.
If I put a few dots or pieces of tape on a stop sign, you're not going to go, whoa, speed limit 45. But
Right.
these systems do. So they do a lot of good things, but there's a lot we need to understand about them
So
that we don't yet.
that's really interesting. So where is the hack in sort of hacking the data that feeds the neural network, or is it in the training of it, or is it just exploiting this pre-trained network based on good information by going out and messing with the real world images and befuddling the network into thinking it's something else? Where does the, what do you call it? Yeah, the exploit take place?
So certainly these models can be attacked at training time by what they call it data poisoning. So you put enough data in there that's going to effectively train the model incorrectly. But
Mhm.
the adversarial examples I'm talking about are this is the model's been trained with good data. So you're not fooling around with the training part of it. You're not fooling around with the input part of it. But if you have access to the model itself, you can do some mathematical analysis that we're not going to go through. It deals with gradient descent and this kind of thing, and you can determine they create these things for this particular problem. They create these things called saliency maps, which allows someone to know which pixels will influence the output the most. And so by learning those pixels, if you have access to the model itself, so you have to have what we call white box access, you can learn which pixels you have to tweak just a little bit, and that's enough to move the model to a different classification. And the natural question here is, well, what allows this? And I think that's what you're getting at. And so I'm clutching an invisible basketball here because
I
as you know from
remember.
years ago, yes,
Yes.
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 So when people think of machine learning models, some people, and I mean certainly researchers don't think this way, but a lot of times they think that if I had let's assume that my decision space was two-dimensional, and I had 10 classes. So one was a cat, one was an orange, one was a school bus. What I'd be able to do is there would be some nice big area, maybe it's shaped like a kidney bean, and any input in there is going to be a cat. And any input in this other triangular shaped thing roughly is going to be a school bus and so on. But that's not what the decision spaces actually look like when you look at them. They're all intertwined in several dimensions. And so it turns out that if you're looking at the set where the model is going to think this input is a cat, well, that intertwines with all these other things. And so you only have to tweak it a little bit in that space to move it from the set where it thinks it's a cat to the set where it thinks it's a dog.
I see.
And And so that's what these researchers are doing. They're just tweaking it a little tiny bit. And because everything is so intertwined, that's why they can go to each individual class that they want just
Got it.
by poking it in the right direction. So yeah, if it were like if it was like the kidney bean and the triangle, that would be a problem, but it's not. And so I did this in 2 dimensions, but you can imagine if you have thousands or millions of dimensions, um, it's an incredibly complicated space, and this is a problem. Um, and I don't know that anyone these days knows how to solve that problem. There have been people who have proposed maybe we try to smooth that decision space. So somehow we expand things so that it's not quite as tangled and gnarly as it really is. But what you do what you get when you do that is you get poorer performance in your models.
So
So yeah.
there's so many questions I have here, and also things that I think would be good to clarify. Like, first of all, when you say you tweak the model, you're talking about, like, with neural networks, there's
I,
as
I
people
should
know,
I
there's
should interrupt you and I misspoke. I used bad terminology, which for an
okay.
academic I should never do. You're taking an image, you've got
Yeah.
the pixels, and what you're doing is you're tweaking the image, not the model.
Oh, so you're not tweaking the weights in the neural network in any
No,
way.
I'm not tweaking them in any way. I'm
I
taking the
see.
pixels, and by identifying which pixels are extremely important for this particular classification, so I was talking about a decision space.
Yeah.
If you tweak the image a little bit, you're effectively sliding around in the space of potential inputs,
Right.
and so therefore moving from one thing to another. But if you can imagine that every pixel in an image, say, if we're talking grayscale, it's an integer from 0 to 255. Tweaking one pixel just a couple of, from 240 to 238 or from 240 to 230, you're not really going to notice that. And if you're only doing it in a few spots, you won't notice it at all. But it's enough to change the input to move it from one decision set to another.
So this is even worse than I thought. Yeah, because if you were tweaking, like, the model, meaning in a neural network, like the weights and how it was trained, you would have to have access to that model, obviously.
Yes.
But you're talking about, yeah, tweaking the image itself. So you could, now this hacker or malicious individual or organization can go and modify a stop sign, as you say, like, visually, knowing that it's going to affect these pixels in the image that the camera captures or something for
Mm-hmm.
this autonomous vehicle or whatever traveling towards that sign, and then that's going to cause the vehicle to say, go 65 miles an hour or something.
Yes, exactly.
Okay,
So
that's
so
interesting.
that's going to tweak the image. And actually, you touched upon something when you said you have to know the model.
Yeah.
So to find these saliency maps, to find these important points, you do have to have what we call white box access to the model.
Okay.
You have to know the weights and the architecture. But so a few years back, I was having a conversation with a fellow researcher, and I said, hey, boy, it would be nice if we could somehow infer the weights. If the model's a black box, is there some way we can learn about the weights? And and I was told, hey, no, you don't have to. And so I actually read the paper that this person said, you don't have to know the weights. Here's how you do it. So there's this researcher at the University of Toronto, Nicholas Pepperno, and he's been at Google as well, but he's currently a professor at the University of Toronto, and he's done a lot of work, good work in this adversarial machine learning space. And he showed that you can build what's called a surrogate model. So you can build your own model. And if you build your own model, you have access, obviously, to the internals of it. And this is how you build it. You use the black box model that you're trying to fool, and you feed you feed inputs in, because what you're getting is you're getting training data. So input, the black box gives me this. Input, the black box gives me this, and so on and so forth. So you get a bunch of input-output pairs from the black box. Then you use those as your training data for your surrogate model. So what you're going to end up with is weights that are wildly different than the original model. And yet, at least in terms of images, for roughly 85% of the time, if you create an adversarial image on your surrogate model, it will work on the original model.
Ah, okay.
So
So
you know,
so
yeah.
that's rough because yeah, I mean it might be difficult to get access to the trained neural network model that there that is being used by an autonomous vehicle or some application
Mhm.
because that's proprietary and hidden on some compute network or something. But in this case, this professor you're saying can kind of reverse engineer the model by creating the surrogate model and then therefore figure out what the exploits can be.
Right. But there's a caveat. There always is.
All
This is
right.
research. The caveat is that while this works well for vision models, so models that are identifying pictures, it doesn't work well, for example, for voice models. So this is called transferability. Can
Yeah.
I create one of these adversarial examples in one model and have it work on the other? Well, for images, I sure can. But for voice, there are recent results that show that it doesn't work. You just don't get the transferability. It has to do with the structure of the models that are used in voice processing systems as compared to what you usually see in image processing models. So when you say, well, you can do this, for example, in an autonomous vehicle, well, it depends on the models. And I know very little about the specifics of the models used for autonomous vehicles. Um, but I would be surprised if this transferability worked in that setting. I mean, it might work for the straight vision, but I assume that these systems, and you know this far better than I do, that there are many machine learning models used in autonomous vehicles, and maybe the vision one can be affected, but the other ones I'd be surprised if they could.
Well, so this is where we can throw out a few terms and define them because of the broader audience, and we're trying to kind of expand the scope of what we're talking about to everybody.
Hmm.
Um, there are, as I understand, I mean, there's two core models. There's what are called convolutional neural networks,
Hmm.
which kind of operate based on sort of spatial images primarily, and then there's recurrent neural networks which kind of work on like time based or sequences of events. And what I'm
Hmm.
wondering, and so these are two different types of methodologies for creating neural networks. And so just suffice it to say there's this one that works well with looking at images and pictures and looking at sort of their relationships in some sort of two-dimensional or whatever space or what have you. And then there's a neural network that's geared for looking at determining patterns based on sequences over time, right? So those are the recurrent neural networks. So I'm wondering, maybe the audible issue happens because it doesn't work well for these time-based neural networks, but it works. This exploit works well for these convolutional neural networks. Is I don't know if that's the case, but I just sort of throwing that out there as a potential, and maybe
So you have a space on my research team, Paul, because that's exactly right. It's the recurrent um, paradigm that causes the problem with
Okay,
transferability. And yes, voice processing is inherently sequential because a voice sample is a sequence of amplitudes, and so um, when you do that sequential processing, you have a problem with transferability. As I said, there's a recent paper by a researcher named Hadi Abdullah, um, who actually there's several, but he was the one that addressed this most directly. And I have to come clean. Hadi was one of my students, so
okay,
Dr. Abdullah was one of my students. So I, I'm not throwing a pitch to him. He's just done great work. So
right, got it. So all right, but still with this particular type of exploit, and for everyone's sort of benefit, we can think of these neural networks, and there's a bunch of inputs. You're training them with, in this case, say a bunch of images, And then the
Hmm.
neural network is this black box where all these sort of mathematical things happen, weights are set, and we can talk about that. But there's an output that says, it's this is a stop sign, or this is a yield sign, or whatever, as an example. That's the most overly simplistic view of what a neural network is. It's just think of it as some black box where some mathematical magic happens. So what is interesting in so with autonomous vehicles,
Hmm.
um, very often, one key function is perception, where the vehicle's driving along and you have to perceive obstacles and objects in front of you. Is that a human being? Is that another car? Is that a deer? Is it
Hmm.
whatever? Is it a tumbleweed? Right? And and so you're perceiving all of this from typically camera image data or lidar
Hmm.
data, right? Which is like point cloud information, kind of similar. I mean, you can have sort of this grid of information like you get from a camera, where it
Hmm.
tells you RGB values at each pixel, red, green, blue, and what the color. But these tell you the distance to things that it bounced off of. So maybe similar in that sense. It's kind of like you can think of it like a form of image, but it's just with distances to things. But
Yeah.
then there's radar data, which is completely different. So I would imagine though that this kind of exploit could happen. Well, can certainly sounds like it can happen with camera image
Hmm.
information, but potentially lidar. Are you aware of any exploits in that, or
I
demonstrations with lidar?
I'm not aware of any demonstrations. There's something in the back of my mind is saying I saw a paper that used LiDAR for something, but I don't think this is what they
Okay,
did. Um,
right.
I want to say it was applied to voice in some way, but regardless, I would think that, as you said, that what you're getting back from LiDAR is effectively, if it's a two-dimensional grid, and your model is effectively, it sounds like it could use convolutional networks there. So it'd
Hmm.
be primarily convolutional networks. That would work well, or that would be exploitable. And I
Right.
mean, let's be clear that when we say that there are two kind of models, the convolutional and the recurrent, um, it is a generalization. And there are, for example, speech processing models use both. So you'll have a couple of layers of convolutional networks followed by the recurrent layer. There are machine learning, there are models for speech. They're rare these days, but they do exist that use nothing but convolutional networks, and it would be interesting to see if those could be if things transferred there. But as far as I know, no work has been done in that, primarily because almost all the systems that people use these days have recurrent flavor to have pieces that are recurrent.
I see.
Yeah.
So this particular type of exploit wouldn't necessarily work with these hybrid models because they have these time-based sequences in place as well.
Yeah. So the research that I read, and again, this is all very new stuff. So I'm
Sure.
not talking about, hey, 300 years ago Galileo did this, or actually probably 500 years ago Galileo did this, because I'm very up on my history. Um, we're talking about stuff that came out in 2021,
Yeah.
2020. So these papers that say, hey, the stuff doesn't transfer well with a recurrent neural network, it's very new. Um, but my guess is that there are things inherent in the recurrence. Um, and actually, we could explain to you, you talked about sequential, but I think of recurrent neural networks as so a convolutional network is I give you an input, it gives me an output. So this black box gives me an output. But recurrent keeps track of what it's seen. And so you give me an input, it still gives me an output. But when you give me the next input, it sort of remembers what it saw and what it gave me. And then after that, it remembers. So it remembers a certain amount of what it has seen. Or what, and sometimes they run them backwards. And so you see what came before and what came after. And you can imagine that doing speech processing, or large language models doing natural
Yeah.
language processing, figuring out which word something is supposed to be is going to be influenced by what comes before it and what comes after it. And so that's how I think of the recurrent pieces there.
Yeah.
That it's that, and so it's this sort of memory of the model that causes problems with the transferability.
Right. 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 Yeah. I mean, I've heard someone use the term, especially with respect to large language models and like what's going on with GPT type AI,
The sky is
as like
falling.
as like as like really fancy auto correct. It's like filling in the blanks for you ahead of, so yeah, it's based on this time based sequence of
If it
events.
works like my cell phone's autocorrect, then
Right.
you
We're in
know, that's
trouble.
not we're in trouble is right.
Yeah.
I'm always amused by I put some text in correctly, and then I hit send, and then I look at what got sent, and it's like, oh, you just changed the
Yeah.
meaning of what I'm sending and several words in there to correct me.
Yes.
Um,
And it's usually something profane.
yes, often it is, and I'm like,
For
no,
whatever reason.
no.
Right.
Yes, there should be a mechanism to cancel your text somehow, but I know how the network works, so that ain't going to happen. So for me, a side note, and I'm sure that if anyone who knows me is seeing this, they're going to be like, "Oh no." Um, I've been I've been learning Italian.
Ah.
I've been learning Italian, and so I have my phone set so it's got like two keyboard modes, Italian and English, and it just sort of toggles back and forth based on what it perceives. So I'll put some things in, and sometimes it changes it to Italian, which in Italian that makes no sense, but it's like, oh, you clearly meant this word, and I'm like, oh, great. So I have a message that's half in English and half in Italian I'm sending to someone.
Oh, that's excellent.
Yeah,
That's
yeah.
excellent. Well, as you know, I mean, I grew up with an Italian grandfather who only taught me Italian curse words. So I don't know what that would yield, but it's
Yeah, it's
but that's
probably
what I've got.
handy.
It
It's probably very handy if
it
you're in Italy.
usually when I hit my head or stub my toe, like he would, it just
Mhm.
comes out.
It
That's
just comes. Yeah, yeah. I find I've been spending a lot of time trying to learn. This has been like my hobby, and it's not like learning the technical stuff, but I do try to learn it. And so while I don't like to give opinions on many things, I will say that the software that tells you you learn a language in 6 weeks, learn Spanish in 6 weeks, learn Italian in 6 weeks. I'm like, there ain't no such thing.
right.
Um, these apps can be really handy as augmenting what you're doing, but having been working at this for a while, and it could just be that I'm foreign language challenged. Um, no one learns a foreign language in 6 weeks.
Well,
So,
are we even going to have to, given like what AI has, like, of course, just 2 years ago, I was in Germany and I could take a picture of like a menu and it would just translate it for me. Um,
hmm
and, real time devices as people speak. I mean, the ability to kind of like through headphones or what have you, AirPods, you're going to be able to, if it's not there in rudimentary form now, which it probably is, in 5-10 years, you're just going to be able to have this automatic translation happen. I have to imagine, because it certainly with what we're doing with what they're doing with GPT AI,
hmm
it lends itself to this kind of translation very, very easily, as an application for that technology. So therefore, and because that's becoming so prevalent, do you really have to learn the language, or is it, why not let the machines just kind of like feed you 100 languages, in your sort of common
well,
representation format?
you're trusting the models in that software to make the correct translation. Um, and if someone can create adversarial models examples for that, you might not
Yeah,
get the response you want.
that's
Um,
true. That's true.
but actually, I think you're right. Though I think you lose, as my personal opinion, I think you lose something if you're not at least trying to learn some of the language. Um, I think I found it cool, and it's a different way of thinking than I usually think. So I'm told that that's good for my brain as I age.
I was just going to say 100%, totally agree. I just, I'm 54, and
hmm
just last year when I was 53. Or
That's
maybe I
a
was,
little more math than we want to do in
no, I
this,
was
I think.
actually was thinking, technically I was, might have been 52, depending on
Right,
how
right.
far ago it was. But
Okay.
I picked up a guitar that I purchased in like 1995 that just basically sat in my basement, and I started to learn how to play using these apps. Learn how to
Hmm.
play the guitar in 7 days. It took longer than 7 days for sure.
Hmm.
But now, and then of course now I have like 5 guitars. I have a set of drums, and but of course, being the technology guy I am, I found it really interesting to record and get like the MIDI and the digital forms of all this
Hmm.
information. I even have a MIDI guitar you can get it all in digital form and start to play with it inside these tools like GarageBand, and you can change notes and do all
Hmm.
kinds of cool things. And it's just amazing what you can do with desktop tools today. Like, I mean, it's almost like you have recording studio capability and editing capability that people 40 years 50 years ago didn't have, right? Just
Oh yeah.
on a laptop. It's
Yeah, it's amazing. It really is amazing. There's software. I know that, for example, classical composers. If you were a composer, 30 years ago, writing classical music, trying to create a symphony, you had to hire someone to help you do the scoring. They're very precise about it. Now there's software that does it for you. If you know what you're doing, it saves a lot of money and also saves a lot of time. Yeah, there are things that have helped with technology. I love that you got the guitar out because I actually too have a guitar that I must have purchased in 1995, and it's sitting in a closet. I have not gotten it out, um,
well, maybe
but
we can get
you know,
like, we never had a band, but maybe we can get the band back together. We can come jam and play some really horrible tunes
I was going to
here in the
say
studio.
I'm with some trepidation. I'm thinking about what that might sound like, and of course, what we might want to play too, because um, I'm very disturbed these days when I like go to work out and I'm listening to music. In fact, this has happened the last couple of weeks. Um, it used to be that the person, like the receptionist at the place where I work out, they were all young kids. And by young, I mean, 20s, 18, 20, that kind of thing. And there'd be a certain kind of music playing. And then I noticed at this place where I work out that they hired someone who's a bit older, maybe closer to our age, who's the receptionist. And all of a sudden, I'm listening to music that I listened to years ago, and it disturbs me because I'm like, oh, those are oldies now.
Yeah,
You
yeah.
know? Yeah, those are really oldies. The young kids are probably like, what is that?
Well, what the good thing is too, if you play poorly with AI,
Hmm.
I'm sure you can put it through some filter and make it play better. Much like in fact, I'll probably take about 20 years off us after I post process this video,
Hmm.
and so we'll look great. So don't worry about that,
That's good
because
because
there's all
it's been
kinds of video filters.
it's all kind of video filters. So filtered. So I'm yeah 20. You do 25 because that's like
Okay,
before my kids were born.
all right.
So I looked much younger. I was much healthier. Um, Kids are wonderful, but they have a tendency to age people. Um, so hey,
Yeah,
how's your family and how are things going?
everything's great. I mean, yeah. So, well, I've aged. I got the gray hair now,
Oh, see,
and
I got the salt and pepper, and it's coming.
well, see, you don't. Your hair has not grayed like at all. You kind of look. I mean, you look great. You look good. You've maintained your youthful vigor. It seems.
Have you ever seen the movie The Picture of Dorian Gray?
Uh, I've heard of it. I've not seen it.
Do you know the story?
I. You're gonna have to remind me. Yeah.
So the story is Dorian Gray has a picture of himself. They take a portrait of Dorian Gray and he puts it up in his attic. And all the things that he does, all the immoral things, all the evil things he does, it doesn't affect him at all. He looks the same, but the image in the attic changes to reflect the wear and tear on his soul
Oh,
that
I
has
see.
gone on over the years. So there, I have a picture in my attic, that where I really look like I'm about 120.
Right, right. Mine's just a skeleton.
So you're okay. Yours is just a skeleton. It's a picture of a skeleton.
Yeah.
You don't show. So actually, when you called me the other day and you were like, or when you were emailing me and saying, "Hey, let's do this podcast," the one thing I said I have to give a shout out to, because it's been years,
Yeah.
um, is Janie's fat-free fried chicken.
Oh, yeah. It's
Yeah,
wonderful. Yeah.
it is
It's
wonderful.
amazing
It
that
is.
you remembered that. Yeah.
Well, it
You
was the
must
best.
really like that.
It was the best fat-free fried chicken I ever had. Um, and so it was a shock to me when I found out it was in fact not fat-free, um, at all.
Nothing's free. There's
Nothing's free.
no.
Nothing's free. That's like there was a muffin shop when I was dating Heather, and they had fat-free muffins, and I was like, these are the best fat-free muffins that ever existed. And then we found out
Uh,
that they're not fat-free at all. It was false
it's
advertising.
fraud.
It was fraud.
No. Well, it's good. At least you think it's, you think you're eating healthy while you're eating it, so it makes it all the more better. And then they can just sort of, maybe when when you look down at the wrapper, it says something like "just kidding," for the
Just
disclaimer.
kidding.
Yeah.
Just
But
kidding.
yeah, no. Well, yeah, but no, the haven't had that chicken in a while, but I do remember it. She used to make it for like these horse races, like Foxfield and things like that, as I recall.
Yeah,
Yeah,
yeah, that was great. That was
those were the days.
those were the days. Those were the days. So getting back to technology, all right. So we're talking about these adversarial networks, and you were talking about or these adversarial examples, and this idea that hey, because researchers have been looking at this. This isn't a new thing. I would say that there have been adversarial examples for a while, but the research space sort of exploded starting around 2014 or 15. So that's when people have really been focusing on a lot of this. Um, and along with this, there's this avenue of research or this branch of research called explanation methods. So the idea is, um, I would like to know how these models think, and I'm using think in quotes
Mhm.
because wouldn't it be nice for these adversarial examples if you said, okay, you're thinking clearly this is a school bus, but the model that's really accurate thinks it's an orange. So you'd like to go to the model and say, what makes you think this is an orange? And you should it'd be nice if the reasoning it gives you, like these pixels here and these pixels here are important for this, then you should be able to go, okay, that's a reasonable way to make a judgment on this image. But if it tells you I think it's an orange because of these two pixels in the corner that have nothing to do with anything else, then you would be able to say, well, that's okay. Clearly, its reasoning is inaccurate or incorrect, so we have to be suspicious of this model. So there are, as I said, lots of people working on ways to get models to explain things, and I don't mean like it's going to speak to you, but it's going to tell you what features it thought were important. Like these are the feature values that made me really think this is what I think it is. Um, this is difficult for humans to do, and yet we do. The analogy I always use is like an art expert looking at a painting, and you say, "Is that a forgery?" And the art expert, if he or she comes back a couple of hours later and says it's a forgery, then you can say, well, why? And maybe you won't understand the answer, but at least the expert is saying, well, these brush strokes here, or the way it's signed, or this. So you get some idea that, oh, okay, I can see what's driving this decision. With a model, what you get is, I think it's a forgery
Hmm.
and nothing else. And so while we understand the mathematics of how you train these models, once they're built, we don't really understand how on what they base their decisions.
I know. So this is one of the things that I've had a problem with in terms of applying this to something like autonomous vehicles. Because it's
Hmm.
one thing to apply a neural network to something that's going to generate output on a screen or But when you're generating output that's ultimately controlling a vehicle that weighs 3,000 pounds, 6,000 pounds or more, traveling at 55 miles an hour, there are real consequences. When it comes time to trying to apply them to something production oriented, where there's physical world interfaces, the verification and validation and sort of knowing that this is going to produce what you expect is unnerving, right? Because you don't know, and I don't know of any methodology for verifying and validating the correctness and completeness of such networks, and such that you can ultimately get to some certification for industries like automotive applications or autonomous or automated ground vehicles. Are you aware of any sort of verification validation methodologies? I mean, you're touching on the fact that it's you're shaking your head no.
No, it's new stuff,
Yeah.
and in fact, it's so as you're talking about this, I'm thinking about the notion, and there have been several notions. People have had several ideas for how you deal with adversarial examples, and I keep using the image example because it's easy to think about. If I
Yeah.
start talking about, I can explain what an adversarial example is for voice, but it's easier to think about two-dimensional pixels and things like that. So, when you come to explanation methods, there are a lot of ways you can try to detect things. So people thought, well, maybe we should put examples in that are intentionally adversary when we train adversarial. So we'll train the network, and then we'll create these adversarial examples, and we'll train them so that they get the adversarial examples correct. That is, when it thinks it's an orange, and we say, no, it's not an orange, it's a school bus. But what happens when you do that is the model tends to be less accurate. It
Mm.
waters down its accuracy. It's like you're confusing it. Um, and then, so another one people came up with was, all right, we're going to combine the example with an explanation. So I've got some explanation method. And if the explanation is reasonable for a particular image, so the model tells me this image is a school bus, and if the explanation is reasonable for a school bus, then I'm going to say, okay, this is a good example. I can use this. But if the explanation is not reasonable for a school bus, then I'm going to say, okay, this could be adversarial. But then about 3 years ago, a group came up and showed, okay, so now I can do this. I can change the image so that the model gets it wrong, and I can change the explanation by modifying certain things. I can change the explanation, so it's not just I'm not just changing the image so it fools the classifier. I'm changing the image so it simultaneously fools the classifier and the explanation method, and
Mm.
so it gives you this is what I think it is, and here's a reasonable explanation for that. And still, it's an adversarial example.
Yeah.
So when you were talking about, is there a way to validate this? I'm like, this is really new stuff, and we don't understand it well.
Right.
And I would, if people are really interested in this kind of thing, there's an excellent keynote address from the Usenix Security Symposium that was held in 2018, and the keynote is given by James Mickens, who's a professor at Harvard. If you look it up, it's online. It's about a 50-minute keynote, and I have to say, as someone who sat through a lot of academic keynotes, I'm sure people in your audience are like, "Oh, well, that sounds like as exciting as watching paint dry."
Right.
But this was actually very entertaining. So I've had people who are totally non-technical watch it, and you can, and it's really entertaining. But what it talks about is how little we understand about how these models really work
Yeah.
and why they work and what effects different architectural choices have on the models. So you go to people from Google and you say, "Hey, why does this model? This is the architecture you used for this particular model. Why did you use that model?" And they might say, "Well, we've got enough computing power to test all sorts of different architectures, and this is the one that worked best." But do we know why that one worked best? And the
Yeah.
answer is usually that we don't. So, so there's a lot that we need to understand about this tool. And, you watch TV now, and every company is like, we use AI to drive our decision. It's like AI is the catchword. We use AI to do
Right.
this. We use AI to do that. And I'm like, okay, but that doesn't mean you're going to get good stuff out of it
No,
necessarily.
no. And I want to talk about that. But going back to the link thing, on the driven.show website where we'll have this episode, of course, linked, I'll have some of these links up that you mentioned. So I like to
Okay,
do that. I
yeah.
like to get the links and references to books and what have you. Sometimes I just pop them up in the video form as well. So anyway, because I definitely want to watch that, and I'm sure others will want to watch that. That sounds interesting. But yes, the whole AI will solve everything thing is, it's part of the Gartner hype cycle. Peak of inflated expectations, trial of disillusionment, and then you get to the plateau of productivity. If you've
Hmm.
seen that before,
Very,
and that's
very
that's that's been
briefly.
happening, as you know, in AI for many years. It's been a roller
Hmm.
coaster ride.
Right. And well, and so I don't know how many academics you have on your show, um, but so actually, because I'm an academic, I can say, wow, this is early, right? Usually, us academics, we get up at noon, we lounge around for a little bit, we teach one course, we go home. That's it. That's what I've been told. So this is early for me. It's like 10:48 here. Um, but actually, in academia, ChatGPT has certainly created quite a stir.
Yes.
There are colleagues, and I don't mean just at the University of Richmond. I mean there are colleagues all over that I hear from who think, in 5 years there won't be a need for computer science programs because ChatGPT can code for you. And I'm like,
Right.
well, ChatGPT and other tools like it are really amazing tools, but they're not always right, and you'll still need people. It will change the job in the future. I don't think it eliminates it any
Yeah.
more than like Mathematica eliminated math departments.
Right.
It's a tool you can use. Now, if I were an English professor, um, that's certainly, detecting when ChatGPT has written an essay for someone. This is even newer than all of this stuff, because if you think about when ChatGPT really burst onto the scenes, um, there's going to have to be some understanding of. I mean, I don't think it's an evil thing. I don't think you say, "Hey, wait, keep it out of the academia." No, it's a tool. We have to learn how to use it. Um, as an academic, I can also say it's fantastic for helping make tests. It really is. Everyone's like, the students are going to cheat. It's like, yeah, well, if I'm teaching a C++ class, and I'm like, copy constructors. I want some good questions on copy constructors. I
Yeah.
have some. I was like, ChatGPT, give me 25 good questions about copy constructors. And
Yeah.
it'll spit them out. And I could be like, no, no, oh, that's pretty good. Yeah. No, no, so it can be helpful.
Yeah. Be careful if you ask it for information on dangling pointers.
I have, so of course, right after this podcast, I'm gonna have to find out. Um, that's great.
Anyway,
Hmm.
um, the well, there's so much. Yeah, I mean, gosh, there's so many topics related to this and it's happening so quickly related to GPT,
Hmm.
AI, and I agree in terms of its utility for code generation. Like right now, it's a great junior programmer if you give it
Hmm.
like a very well defined thing to create in different languages, right? I want it in Java, I want it in Python, I want it in
Hmm.
and what C++, and um, and that's just going to get better. And but with programming, there's always been layers, right? I mean,
Hmm.
I remember when I was in college, people talking about, well, we used to program in assembly language and we can do all these things that you can't do using your fancy high level Fortran and C++ languages, right?
Hmm.
And then of course things like Java come along, which were a little bit higher level, and Python, and then there's these frameworks and libraries, and you're just, you leverage these things such that you can like let the not have to be mired in a lot of the low level details, and you're kind of like climbing the evolutionary ladder of programming. And in some ways I think of this GPT technology as that right now. You have to co-pilot it. You have to, you have to know kind of how to tell it to how to still stitch together these programs. It's not going to create. You can't just say, "Hey, create me an autonomous driving vehicle application," right? There's a lot. There's about a million steps in between, right? So that you
Hmm.
have to coach it along the way, and but even then, so I think it becomes like another high level programming language tool. Like if you remember 4GL, fourth generation language
Hmm.
programming, like that was like a big topic back in the day because you could graphically draw things and then code would be generated from it, right?
Hmm.
And people said, "Oh, this you don't never gonna have to learn how to program. We're just gonna draw things and it'll program it for you. UML diagrams will just generate code." And it
Hmm.
never and machines historically have generated code poorly. But what's interesting about ChatGPT, or just GPT AI, I should say, ChatGPT being the brand of OpenAI's
Right, right.
GPT, but GPT AI it's basing it on how other programmers have created things. So it's not sort of it's not as ugly this ugly machine generated code that you used to have with these other tools. It's better looking code and it's more well structured and so it's a useful tool. I think any from my perspective, anyone in our space programming should give it a serious look to help augment your programming efforts, moving forward, your
Oh,
development efforts.
I agree. I think you hit that nail on the head with that. I think that programming in the future is going to mean that you're going to give some things to ChatGPT, as you said, relatively simple things, or things that you would be like, it's going to take me 15 minutes to code. I know what this should be, and you have ChatGPT coded. And my experiments with it, which are not extensive, but uh, but my experiments have shown it will not only generate the code, but it'll explain to me how it works.
Right.
So like I was testing, if I gave this on a Java test to students, what would they get? And it's code that works, and then it explains to the person how it works. So you could think of that as a learning tool. But I think that programmers in the future, as you say, well, they'll be using this, they'll be validating it, and then they'll be putting pieces together to build the bigger systems. I'm actually curious if I haven't done this, but it occurred to me like 2 days ago. I should ask ChatGPT to give me code to make an accurate large language model like ChatGPT and see what it comes up with.
Right.
You
That's
know,
interesting. Yeah. Well, and you've probably heard of these open source alternatives like Hugging Face.
I have not heard about Hugging
Hugging
Space.
Face. Check it out. It's a so and there's probably many others, but it's a repository for a lot of open source AI
Mhm.
tools and libraries, and they have GPT engines, right? You can get these open source GPT engines, sort of train, and run them and host them in your own environment. Um, and they might not have the level of breadth that say Chat GPT or some of their competitive ilk have,
Mhm.
because they're designed to field questions from the world at large. But you can train it on, say, specific code libraries that you're working with, and then ask it to generate code based on some of these things, and then therefore tailor it really for your problem sets and the problems that you're trying to solve, because it's been trained on the code libraries and relevant materials, and it's much more hyper focused, and therefore you get more accurate results, right?
Yeah,
Is sort of what I've seen and what I've heard from others too. So
yeah, and it's fascinating you mentioned that. I've been impressed by the the breadth of knowledge of ChatGPT. I've had students. So in what I'm doing, students have to code um, systems that do automatic voice processing. Now, of course, they're not coding this from scratch. There are, in Python, there are speech processing libraries and things like this, but it's hard to know all of them. And, just last week, I had a student come to me and showed me some code that did something really cool. And I was like, that's interesting. I was not aware of this library. And she said, oh, I asked ChatGPT for, I'm trying to do the following. And ChatGPT gave me, you want to look at this library and this library. And I
Yes.
was like, that's totally cool. I mean, here's an example of, didn't code it for her, but certainly pointed her in the right direction. And it was really neat. So this can
Absolutely.
be.
Going back to that music stuff that I mentioned earlier, I do have a MIDI guitar, and I wanted to generate guitar tabs from tunes that I was playing. There was nothing out there that I was aware of, and there was a library out there from, I forget the name of the company, but I could just get it right from Maven, the Maven repository, right, and link it in, and boom, I had these libraries in my program that I was stitching together just like instantly. It would have taken me, I don't know, weeks of research to find such a thing, right, and then to
Hmm.
integrate it.
Hmm.
So
So what I think you want, though, I'm just going to offer a suggestion. Um, what I think you want is software that's going to take your playing and like convert it into something Eric Clapton would play or something like
well,
that.
of course. Well, there's the filters. There's what's going to make it better, right?
Right?
I mean,
Right.
there's already, as you probably know, that there are Beatles songs, I think, and I think I heard a Nirvana song that was just created. Someone said, "Create me a song in the style of Nirvana," right? And
Oh
and
yeah.
and and I don't know which tools they're using to generate this music, but it sounded like a Nirvana song, and then there was a couple Beatles songs, or they said, have Patsy Cline sing this song from Vanilla Ice or whatever, and it's hilarious, of course. But so
Yes.
there's all these mashups and things that people are doing with this, and so if they could do that, they could certainly make the crappy music that I'm creating sound a little better.
Yeah. Well, I mean, it's all that generative AI stuff that's really amazing. You mentioned it before, touching on generative AI. Um, have you been to this site? I'm guessing that you probably have. This person doesn't exist.
No, I haven't. No.
Okay, so there's this site. This person doesn't exist,
Okay.
and if you look at it, it's pictures of people that was generated by generative AI. So that these people don't exist,
Hmm.
but and so this dog doesn't exist, this cat doesn't exist, this person doesn't exist, etc. This meme doesn't exist, and so but these pictures of people are incredible. You
Yes.
look at these pictures and you're just like, a computer generated this picture of a person. It looks photorealistic, but they don't really exist.
Yeah.
And that's the so this whole notion of generative AI, the generative adversarial networks, is people have called that like the biggest development in the last decade um, in machine learning in general. And of course, it's used in part for ChatGPT, but this notion that you can pit a couple of models together in such a way, effectively they're competing against each other. One of them is acting like a forger, and the other is acting like a police person trying to detect forgeries, and they make each other better. So the forger comes up with an example, and if it's detected as a forgery, well, the forgery is penalized and they have to be better. But if a forgery fools the police person, then the police person's penalized and they have to get better. So they make each other better till eventually the forger can create these examples where the very accurate police model is is right 50% of the time and wrong 50% of
Yeah.
the time. That's the best you're going to do. But that idea has turned out to be extremely powerful.
Oh
So,
yeah, and it's at your fingertips. I mean, there are
hmm.
tools like Midjourney,
Hmm.
and Dali, right? That you can just ask it to generate an image. I mean, I do this now for PowerPoint slides and presentations where I can get non-copyrighted imagery for presentations that looks beautiful.
Hmm.
And in fact, every Driven episode, the cover image is always generated from Midjourney.
Very
So
cool. Very cool.
with the exception of the conversations,
Right.
I've been using the picture of the actual human being with whom I'm speaking. So
So
we'll get your best side.
there is no best side. It, in theory, I might not even exist. You could come at the end of this podcast, you could say, so I just done this 2 hour podcast with a generated personality. I'm some avatar that, you know,
Now
that
I'm
would be very
wondering.
cool.
Yeah,
Now
yeah.
that's right.
It's no, it is true. I mean, that's coming, right? I mean,
Hmm.
for certain, we're just on the cusp of very easy to generate realistic deep fakes.
Yeah,
I
yeah.
mean, easy. I
That,
mean, and
they're actually there.
yeah.
And there are researchers at Stanford who, for the past couple of years, I'm sure they're elsewhere, but the ones I know of are at Stanford, who are looking at detecting such things.
Right.
So, you take a picture of a person, and so you could conduct an interview, say whatever you want, and then you put you get a picture of a person, a famous personality, they meld that to your body and their voice, you get some voice samples, and all of a sudden you have this person
Yeah.
saying all this stuff. It's already here. And
Yeah.
so the research is, can you detect that?
Right.
Uh,
Right. Yeah. And you do have to be careful. I mean, video is harder than images, but even with images, still right now, like I asked this tool to generate an image of a deer walking in front of a car, right? Because I wanted
hmm
to talk about deers crossing in front of autonomous vehicles,
hmm
and it looked really great. And I didn't notice until I was presenting it on the big screen that this deer had like a half of a fifth leg. At least I think it was a leg, but it was, but
Well, you'll be editing that one out.
well, it was too late. It was up on this. It was up, and I was like, wait a minute. Okay, that's I don't know what that is, but it was. So there's some creepy things that happen that you kind of that you can easily look for. I mean, people with six fingers and all that kind of stuff, happens. But obviously, that's all going to get weeded out and smoothed over, and then the images will be more perfect. But the video is still kind of hard. I haven't seen very many, and I haven't looked very hard. I'm sure they're out there. Really good, accessible tools that generate 10 15 seconds worth of video from a text command, right? Like usually it's something creepy. I've said, show me it, create a video of like a human being walking in front of like a car on a crosswalk, right? And there's like some ghost like human image, and like they shift all around, and the car's like moving sideways. So
hmm
it's like this nightmarish
Like a
video, but
Salvador Dali video of
it is.
this.
It is. So but maybe there's better tools out there than the one I was using. But yeah, that's coming very quickly, where we're going to be able to see. You won't be able to tell the difference between me or you talking right now. If you give it a script and say, or just don't give it a script, right? You just have it respond in the style of Doug Szajda.
Yeah, because and my style is so unique too. Um, I actually, it's funny. We've been talking about a lot about adversarial examples and stuff, but I think about what I know very little about is your space. I know I have some ideas about what someone would do to design an autonomous vehicle, and I've thought about things like, we have autopilots that can fly planes. And so you might be tempted to say, well, if you can fly a plane, you can drive a car. And it's like, well, no, right? Because a plane, there's controlled airspace. You can keep planes away from each other. Um, you hopefully are never in a situation where you've got, like 100 planes within so many meters of each other having to fly.
Right.
it's a autonomous vehicles is just a really, really hard problem. So what I was going to ask you, because that there are these commercials now, and people are out sitting in their front seat and they're like clapping their hands and everything instead of driving. And I'm every time I see that, I'm like, I'm not sure how I feel about that just yet. Um,
It's
so
it's yeah, it's I think, and I've thought about this. I think it's harder than rocket science and brain surgery for sure. So, because why do I say that? You're making a brain versus, and brain surgery exists. People know how to do that. And people know how to launch rockets, and open space is obviously there's tremendous complexity with that. But when you're dealing with something automated on the ground, it's very complicated for one simple fact. Where are there more human beings? On the ground, in space, flying around in the sky, underwater? Just pick one.
well, it's not going to be underwater. Space. Give
Yeah,
me a second.
yeah, no, it's the grounds, right?
I'm
And
an
so,
academic, so I have to consult the latest
of
research.
course, well,
Yeah, yeah.
everything should be, analyzed. So, people are everywhere, right? In cars and walking around, and there's then you've got people in the vehicles themselves. So um there's just like a lot of liability in a lot of situations because humans are unpredictable themselves.
Hmm.
One of the driven episodes I did, episode 5, just talked about the cruise pedestrian incident that happened in early October out in San Francisco. I don't know if you heard about
Hmm.
that. And it's just like there's all these, they call them edge cases, but it's just un, unpredictable situations, right? That are just going to happen. And so it's incredibly complicated. I do not think neural networks are the silver bullet for these things, as a lot of companies have sort of, um, I think because they're trying to tell a story and get venture capital in some
Hmm.
ways.
Hmm.
I'm not saying that they're doing it maliciously, but there's this belief that these neural networks can sort of predict all these possible situations that these vehicles can get in, and then they have methodologies for dealing with the exception scenarios, or they might call them long tails or what have you.
Hmm.
But even those methods can't, don't address all of the because you still have to think through the situations that can arise, and they often don't think through them until they actually happen, right?
Yeah,
and
yeah.
and so it's very complicated. And so I do not think that, I think neural networks are very good at pattern recognition, and I
Hmm.
think that there's some utility in leveraging them to detect, very specific, simple things, and then integrating that with a larger sort of framework of software, and also having an independent, watchdog type system monitoring what's going on, right? So it's
Hmm.
like a diverse, redundant scheme for implementing autonomy.
Yeah,
So yeah.
yeah. No, I was going to say, I think about your problem. You just the general autonomous vehicle problem, especially like it's dark, it's raining, I'm driving on a highway with a lot of people next to me and a lot of people coming in the other direction, and so the image that an autonomous vehicle would be getting, it's points of light, lots of reflections off raindrops and everything else. It's incredibly complex. Even if you've been driving for years, to make sense of what you're seeing. Where are the lanes in the road? That's difficult to see. It's difficult to see the signs. It's difficult, you've got glare, et cetera, et cetera. So it's really difficult for a person who's been doing it for many years to drive. Getting a computer system to successfully navigate that. And so we're not even talking about, it's hard enough to do it when the weather's beautiful.
Right.
When you've got these kinds of situations, it's even more difficult.
Well, the what's interesting is that we can leverage in autonomy different types of sensors, right? That go beyond with the sensors that we have. Because
Right.
what do we have when we're driving? We have, two eyes, hopefully, sitting in the front seat of the uh, the one location of the car over, the driver's seat. And in this case, you may have cameras, but you can position them all around the vehicle. But
Hmm.
then you have GPS, right? A high precision GPS, which can tell you, regardless maybe of the weather, that you're in a lane, right? But you don't
Hmm.
want to just rely on that. You do want to be able to like detect lane lines. You have LiDAR. There's some pretty sophisticated methodologies whereby a LiDAR beam, they have what's called multi-pulse technology, where each beam that goes out, there's like multiple pulses, and maybe the farthest reflection that you get is the distance to something out there, because maybe the reflection to something that occurred a little sooner was a raindrop at that moment, right? So
Right.
you have sort of this filtering, and then radar, right? So like radar, lidar, camera, GPS, and maybe even increasingly like infrared type camera, um, is you really need all that, I believe, for effective autonomy.
Yeah. But,
um,
well, and for redundancy, right?
Redundancy,
You
yeah.
don't want a single point of failure that the LiDAR doesn't detect it, and therefore we crash. It's got to be several different ways of, so if this fails, then these others will catch this, or, will safely guide me through this situation, that kind
Right.
of thing.
Yeah, and then there's
Um,
V to X, vehicle to infrastructure, where X is infrastructure or vehicle. So where you
mhm.
have communications from the vehicle to infrastructure devices. And that's more viable with these geofence type applications than, say, what Tesla or whatever is trying to do, right? Because if you're operating in a controlled environment where it's 1 to 5 miles radius of operation, you can put things in the environment and the infrastructure to help the vehicle, to help tell them that there's something in the crosswalk there, or and there's communications with the infrastructure, sort of smart devices.
Yeah, I had heard years ago people talking about, and I haven't followed it, but I'm sure you know something about the smart highways. So
Yeah.
it's, as you say, it's sensors that the cars can use to help. Um,
Hmm.
so
But then
yeah,
now there, as a cybersecurity guy who's looked at like distributed networks and things like that, I mean, there's where there's going to be certainly a cybersecurity concern if that rolls out at a larger scale. Right now, these communication networks, there's methodologies called DSRC and CV2X,
mm.
and what once that becomes more, CV2X is the new standard for communications.
You
That's
realize you could have just thrown out any letters and I'd have been like, oh yeah, because I don't know these standards at all.
well, no, yeah, that's
XP38T is the newest standard, and I'd be like, okay, okay.
right. Well, yes, the R2D2 network and the
The R2,
C3PO,
exactly. And that
they're
should
all
be your
emerging
your
standards.
advertising. Perone Robotics. We use the C3PO network. With our
Yes.
new C3PO technology, we can,
we
you know,
we'd probably be sued by, I guess it's now Disney who owns the brand,
yes,
right?
yes,
So, or
yes,
Lucasfilm. But
right.
no, I think but these new standards, or these communication standards, as they become more widely deployed, will become more attractive to people who want to exploit and hack them.
Yeah,
So you're going to be busy.
yeah. Well, we already are. And this is so one of the first things someone learns if they're taking a security course is that, because you'll hear people say, well, why can't we prevent this? Like, why can't we prevent people from breaking into computers? And I'm like, well, houses have been around a lot longer than computers, and we still can't prevent people from breaking into houses. I mean, we can raise the bar, and that's so when you talk to security professionals, they'll say, well, security is all about risk management, and it is.
Right.
It's right. It's I can't prevent everything. I may only be able to detect some things, but I can't prevent them. I try to raise the bar. So if your house, if I want to prevent someone from just walking into the front door of my house, okay, so I put a lock on it. But now I want to protect it a little better, so I put an alarm system in, and but then if I start, like what am I protecting in my house specifically? and as I'm protecting more valuable things, then the amount of resources I'm willing to devote to security goes up.
Right.
But you're never, I can prevent X.
Right.
It's
Of
not going to
course.
happen. So you look at a system like this, and potentially these autonomous highways, not autonomous highways, but you know that enable this. Um, it's a really big target, and so you have to wonder what is the how much are you going to pour into security? And and again, there are never going to be any guarantees. And of course, the other thing is with security, you got to build this stuff in from the start. So you're going to be, say, modifying highways that weren't designed for maybe what you're putting in there. And that can affect things. So if, as an example, I can protect my house well, but if the United States decides it wants to make my house the gold repository, um, that's going to be really hard to secure. Right? I mean, that's you really have to say the gold repository has to be built from the ground up, thinking about these things. You
Yes.
start to bolt it onto my house, you've got a problem.
Yeah. Yeah. it's
Yeah.
no, it's very true. And the fact is, I've seen security and unfortunately in some instances with some of the deployments, safety, you see it. It's not necessarily an afterthought, but it's there's definitely some reacting to after the fact, because it's hard to think through again all the scenarios and all the possible
Hmm.
situations that one can encounter. You can put up firewalls and you can close off your network, but there's all kinds of exploits and hacks that people are going to have, like, for example, adversarial neural networks, right? Someone's going to go that they've made their vehicle super secure, and now someone puts a piece of tape on the stop sign, and they think it says go 55 miles per hour, right, or whatever it turns
Right.
out to be.
Hmm.
That's horrible. Also, the fact is with like lidar, um, it has been, mirrors and lidar don't work very well, right? So once people start to figure out, you know, like you saw people in San Francisco putting traffic cones on the hoods of the Cruise autonomous vehicles because that would
Hmm.
cause them to just stop. Well,
Right.
you get people with mirrors and they know these vehicles have lidar. It can cause all sorts of potential havoc depending on how they've accounted for it. And are they really designing for all these possible malicious things that human beings can think of? That's hard.
Yeah.
That's hard to
Well,
do.
yeah, it's hard to, the security people will tell you always that the person that's trying to secure a system, whatever that system is always at a disadvantage because the adversary only has to find one way to break it. And
Right.
then the security person has to protect against all of these things. And invariably, there will be mistakes. Invariably, people will find ways to get around systems, especially if they think that that's worthwhile. And unfortunately, we live in a world where there are going to be people who are going to find it worthwhile to create havoc. Um,
Well, the way
uh,
information flows today with, social networks and what have you too, and just the media, as soon as, you can have 100,000 really good things, accident preventions happen with a vehicle.
mhm,
And obviously that's not going to make the news because that's boring. But one incident makes the news, and then there's like a shutdown and a recall on vehicles and investigations because the severity becomes, existential for the organizations. Not to mention, of course, if it's the severity of an accident, if it actually kills or hurts somebody, right? So
mhm,
so yeah, the risk can be high unless you can control the risk, and by how where you operate, how fast you operate, maybe,
mhm,
and so you're limiting the risk in that sense, and then also adding some mitigating efforts like independent safety watchdogs or security watchdogs that are monitoring what's going on and shutting down in the event of a detected issue. And failing safe, stopping the vehicle versus like some of these vehicles were designed to, if they had an issue, it'll pull over to the side of the road.
Hmm.
Now you would think you would want to do that. Of course, if you're on I-95 or the 101 and you're not going to want to have the vehicle stop in the middle of the road, right?
Right,
That's a
right.
bad, that's a bad fail safe situation.
Yes. Although I have seen people on the Beltway in Washington
I've
stop
seen it.
and
Yeah.
back up acceleration lanes.
It's even worse.
Yes.
But like in San Francisco, with this recent incident, the vehicle pulled over to the side of the road and actually someone was under the car and it actually dragged them like 20 feet.
Oh,
That
oh,
was the
yeah.
cruise incident, unfortunately. And so yeah, if it had stopped and just sort of and I think that's what they decided, that they're going to reprogram all the vehicles to just stop and not engage in this other more fail operational maneuver, I guess you could call it. So anyway, a lot of different situations to consider, which makes it a very complicated problem to solve. And then throw neural networks on top of that, and you're in quite a pickle.
Well, so you are in a pickle, but there's also, and I understand what you're saying about the one incident generates a lot of publicity. Um, so historically, one thing that has plagued the computer security um, domain is that there isn't um, this same study of the things that go wrong. So the airline industry is one that I use. Historically, when something happens with an airplane, there are a lot of people that, there's no hiding it. The plane
Right.
went down. Why did this happen? And because of it, we have an extremely safe airline system. I mean, some people who work in it would say, well, with the amount of traffic now, it's hard. It's like, but still, the odds are that you will never be. You could fly every day for the next 1,000 years and not be in an accident. Um, so when my plane goes down next week, just you know, but this happens because when an accident happens, it's carefully scrutinized, and they take measures to make sure this thing doesn't happen again.
Yeah.
Whereas in computers, for years, if you were hacked, this was a really bad thing. So you didn't want to publicize what exactly happened or how the hack worked or that you were hacked at all.
Right.
So an attack that worked on one company or institution also worked on the next one and the next one. And then you have this big installed base. And so there are companies that are vulnerable to attacks that we knew about 30 years ago. And they're still vulnerable to it, maybe because they don't know, maybe because they haven't changed there's inertia to changing your software base. But this is something that has plagued computer security, that there was no group that would say, hey, that company was hacked. What exactly happened there and how can we prevent that? Security professionals talk about some of it, but in general, for many years, um, many, many organizations did not want to publicize this kind of thing. It
Yeah.
made them look bad. Our systems were hacked. Instead of saying, now this is something that could have happened to 20 different organizations, it just happened to happen to yours. Let's make sure it doesn't happen again. This particular thing doesn't happen again.
Right. The airline analogy is interesting because I think of that with respect to automotive,
Mm-hmm.
autonomy. And right now there's 40 some thousand deaths in the US per year
Mm-hmm.
with automotive accidents. And if you woke up every day and if every week you heard that two planes, 747s, crashed with basically the equivalent amount of people who die each week in cars,
Mm-hmm.
which you would never fly, right? So
Right.
that's what's happening in cars, right? And it just I guess you don't hear about it, but on the flip side, with autonomy, you are going to hear about like just about anything right now. And so with planes, they went through this sort of this the trials and the tribulations from the Wright brothers when they had crashes, the 60s. There were a lot of
Hmm.
70s plane crashes, and then it's almost like almost virtually stopped in the US, right? Anyway, I mean, like we don't have any major airline crashes. It's been a while.
Yeah, I mean, they happen, but it's rare. But yeah,
It,
as you say, you talk about how many people die in auto accidents in the U.S., and then you go, I mean, it's been years since we've had a fatal plane crash in the United States, fatal passenger plane crash, and small
right.
planes go down from time to time.
Yeah.
But you know, and part of that is because they've learned valuable lessons, um, and unfortunately, a lot of those lessons were learned at the cost of lives. And I
So
think that this is going to happen if there's ever a large rollout of autonomous vehicles, if the technology gets to where this is practical for, you know, everyone just gets in their autonomous vehicle, there are going to be things like this that are going to make the system safer, but it's going to likely come at the cost of lives, unfortunately. But hopefully far fewer lives than are what are lost, you know, in just by humans driving.
but I wonder, and I don't know the answer to this, but like if in the United States in particular today,
Hmm.
because of the access to information that everybody has,
Hmm.
we have instant access and like detailed access to so much information, right? Like
Hmm.
gory information sometimes, right? And not such that it becomes, will people just, say, forget this with autonomous vehicles. We don't want anything to do with them, right? And then it won't the industry won't certainly go through those same sort of trials and errors that the airline industry went through, but in fact, it'll something they'll have to go through something different and approach it differently to even be able to launch this, technology.
Yeah, that's hard to. So now you're touching on, and I'm certainly no expert on this, and pretty much have no knowledge of it, other than observing humans, right? You're talking about there's a technology piece, but then there's the piece. Will humans, will the population, will the general population accept certain things? That's hard to say.
Yeah.
We are not always rational beings. I've said for years that. Um, that that all you need to know about humans is this one phrase: $1.99. $1.09. It's not $2. It's $1.99.
Yeah.
Everywhere I go, $5.99, $4.99. It's like, oh, $5.99 is $6. But and it's been shown empirically, and it's been shown through research. You price it at $5.99, you sell more than if you price it at $6.
Oh, right, right.
Right? So when you talk about rational human beings, it's like, come on, you know, Mike, that it's not $2,000, it's 1999.99. I was like, that's $2,000. But so you're asking, will, you know, how will people react to, will people react rationally? Will they say, well, look, 40,000 people died last year, but autonomous vehicles killed 200 this year, and it's just rolling out? Will people say, well, that's an acceptable trade-off, or will they be like, no, no, I'm not getting into that car? I can't answer that, but I, you know, when I think about $1.99, I think, I don't know, I don't know.
I actually think that people will, because they have access to so much information quickly and a lot of details of it, that it's going to be harder for autonomous vehicles, and therefore it might should drive the business approach even, right? Like how you approach this. Like maybe these robo-taxi companies should just keep people in the vehicles for a while, safety drivers, as opposed to trying to take them out of the driver's seat. Um, but anyway, yeah, it's uh, it's interesting. I mean, one of the things that we didn't talk about much, but you're the chair of the computer science department, right, at University of Richmond?
I am, although I'm on sabbatical this year, so we have an interim chair this year. But yes, I am
Okay.
the chair. I am the chair. So sabbatical, because I'm an academic. I'm sure people. It's bad enough when I'm an academic. You know, I show up, I teach my 1 hour, and I leave. Now that that's on sabbatical, I pretty much get up whenever I feel like it. I sip pina coladas all day, and then I go back to sleep. That's what I do. Uh, but actually, I am on sabbatical this year. But I am the chair. I'm proud to say I was the first chair of the Department of Computer Science because prior to 2022, we had been a Department of Mathematics and Computer Science, and we finally made the move that we probably should have made a while ago, which is moving to a Department of Math and Statistics and a Department of Computer Science. So I am the chair, and I can say that for anyone who's watched the all those shows out there that talk about what it's like to be a department chair, they don't actually reflect what it really is like to be a department chair. I watched this special, and it's like, okay, so department member, faculty member's wife passed away, and now he's an alcoholic, and he's sleeping with the department chair, and I'm like, no, that's really not it. There drama? I'm sure there is, but it's nothing like that. It's nothing exciting. They wouldn't make a TV show out of it.
Right, right.
It's like, so the crisis this week is 5 students can't get into this course. How are we going to fit them in? An
Right.
hour on that, and then we do fit them in, but viewers would be like, yeah, I'd want, should we use Java in our first class or should we use Python in our first class? Okay, that's going to be, we're going to be there. It's life-altering decisions. Which one are we going to use?
But what's interesting, and this show is about AI, robotics,
Hmm.
autonomous vehicles, and more. And so the intersection with a lot of things, like we had Nolan Bushnell on here. We talked about the intersection of gaming with AI, and it was really interesting. And so with what you're doing, teaching the next generation and about computer science, what I'm wondering is how are you thinking these things like AI and GPT are going to shape the curriculum? Like, should they be learning? Should and maybe they are, right? I don't know, but should they be um, knee deep in figuring out how to leverage this technology for programming, like we kind of touched on earlier, or is that coming, or how do you think it's going to shape the department and the program, not just at University of Richmond but other schools?
So that's a great question. I certainly think that things like these large language models like ChatGPT are going to become a part of the curriculum. One thing to note is that a computer science curriculum, unlike many disciplines, although some of the science disciplines are certainly like this, we have a tie to industry. We don't want to be oblivious of what industry is doing. Um, we want to create graduates are who can do what industry needs, and that means that we have to be aware of what they do. And most of our faculty have spent time in industry, some very recently, and some continue to consult for industry. So we like to maintain a close tie with industry, um, but we also avoid trying to teach things um, that we would consider very transient. So, for example, years ago, I had a student say, "Why don't you teach Dreamweaver for making website?" Right, right. And so I
Right,
thought, so yeah, okay. So we're going to give you 2 courses on using Dreamweaver, and then 3 years from now, it's completely useless.
right.
So we try to base our curriculum on teaching foundational material, things that are going to prepare you. If you're a computer scientist, I think that history has shown there is no doubt the field is going to change during the course of your career. And so what we can do for you is certainly there's an amount of technology you have to learn, but we're also trying to prepare you so that you are able to handle the changes that come along.
Hmm.
You're able to adapt. This new thing that comes along in 5 years that none of us know about, you will be able to handle that because you have the techniques and the tools and the problem solving ability and the approach to problem solving that will get that done. And I think that, ChatGPT is one in a long line of tools that have come out that have helped people do things differently. Um, we're certainly, like many departments, we're certainly grasping or grappling with the issue of how are we going to incorporate it in our courses. Do I want to allow beginning programmers to use ChatGPT? I don't think I do. Um, so, because while it's a great tool, if someone can't say write a function that finds the maximum number in a group of numbers,
Right.
they have to be able to do that on their own. Now, but again, it's so new that these conversations are going on everywhere. But I do see that in the future, much like certain tools now are standard part of the curriculum. So if you're in a compilers class, for example, and you're teaching students how to write compilers, there are compiler generator tools that they use to do this. There will be, as you get to the more advanced classes, I imagine they will allow you to use ChatGPT, and more than that, say, okay, so here's how you effectively use a tool like this. It's different than previous tools because, as far as I know, and I'm grouping, when I say ChatGPT, I'm grouping all these code generation tools.
Right.
That's
GPT AI. Yeah.
right, right. There's all, um, that's a new thing. The ability
Yeah.
to have code generated is a new thing. So how do we use that? Um, and so we have to think through how we want students to do that.
Yeah.
Um,
Yeah, no,
yeah.
I think back to my own schooling, of course, I mean, I was in electrical engineering and computer engineering, right? So
Hmm.
there was a lot of little hardware involved, but like learning about assembly language and operating systems, like how they're constructed, was something that we just learned. And I think that that was valuable. I'm, of course, not programming in assembly language. I'm not making my own operating system. None of our, software engineers are doing that. Of course, they're programming at this higher level, and but it's useful to know, I think, how all that stuff underneath works. But the
Yeah.
same token, the engineers are focused on these higher level tools, and I'm really thinking that, in our own company and I'm sure in others, starting to kind of leverage these GPT AI tools um, the right way. We're not asking it stupid sort of philosophical questions or even intelligent philosophical questions. We're not
I was gonna say
asking them.
that. Yeah.
Yeah, there's both, but we're asking it to generate code and structures and things like that. But anyway, I think from a programming standpoint, it's going to become a very, very useful tool. I don't know exactly how, and I don't think everyone does, but I think certainly initially to generate simpler simpler components of code that you then stitch together and architect into larger, more complex structures will be how it's certainly co-pilot in the immediate, how it's leveraged in the immediate future by a lot of programmers.
Yeah. Yeah. Well, actually, you touch on interesting things. From an educational standpoint, CS is a young discipline, right? I mean, how long has math and chemistry and physics and a lot of the humanities been around? For many, many
Yeah,
years. CS is young. So even as late as I remember in around 2000, um, like publishers were getting faculty members together to figure out how should we teach Java? Like what should our book have? What do you
yeah,
want? And it was so new that there were opinions all over the place. You should do objects first. You shouldn't do objects. All sorts of stuff. Um, and much like electrical engineering, which when I was in college and we walked uphill both ways to get to the door. But when I was in college, people were already talking about, well, there's so much to learn in double E. Maybe it should be a 5-year program.
right,
And so we have a similar problem in CS, which is there's so much to learn and we can't teach it all. So,
yeah,
how many of our graduates will ever code in assembly language? Well, probably not many unless they're designing compilers. Um, how many people will design an operating system? Well, not many, um, because that's not what people hire you for now.
right,
And and so the question is always what skills do we have to
yeah,
well, there's this tension between what do we want them to know to be good computer scientists. It is a science. It's not just software development. It is a science. Um, at the same time, do they need to know, like, if you leave out certain things, like if we never teach how the machine is put together and we never teach assembly language, then it's sort of like a race car driver who gets in the car and knows how to drive the thing. But when you say, well, what kind of adjustments do you need? Well, I don't know how this thing works. I just know I step on the gas and I turn the wheel, and that's how it goes. If you're learning the science of computing, shouldn't you understand something about how the tools you use every day, like compilers or interpreters, are built? Something of that. It's a tension, and I wouldn't say that it's something we've solved or something that anyone's solved. Because the discipline is young, I would say that any computer science department that isn't really seriously considering its curriculum every few years, like what should we take out, what should we put in, they're falling behind.
Yeah.
And we're undergoing a curriculum review this year, or I should say, they're starting a curriculum review while I sip my pina coladas. And but but the idea is that these questions are coming up. Um, Certainly, some courses that have been required for 25 years, now people are saying the time could be better spent helping them learn X. And it's never a package. It's never they need to learn this package or they need to learn Dreamweaver. It's there are foundational things. And in some sense, ChatGPT and these large language models and generative AI, this is foundational. You don't have to be an expert in it, but I think you're going to have to, if you're in software, you're going to have to understand what they can do, what their limitations are, in addition to some how do I actually use this. But this is a this is not an easy problem, and it's not something I claim that we have solved or that anyone has solved. It's calculus has been around for hundreds of years. Python hasn't, and
Yeah.
ChatGPT certainly hasn't, and generative AI hasn't. So we're learning. There's much to learn.
Yes. Yes. And I think with what's happening with AI, of course everybody tries to grab the invisible crystal ball,
Hmm.
right? And the
I think
invisible
I
basketball
think that's
or
right.
crystal ball,
Hmm.
and predict the future. And this feels kind of like something that's really profound, like not
Hmm.
even like bigger than the World Wide Web, bigger than the personal computing explosion.
Hmm.
It's definitely another revolution, an AI revolution, maybe on the order of the industrial revolution, that kind of wave. But back in the mid 90s or early 90s, when the internet of course was around, but when the World Wide Web with the browsers and everything became a big thing, I was in grad school, and immediately, like a couple years after, you know people I knew went out and made a ton of money and did a lot of things with that sort of technology. We weren't learning like how to leverage it, or in any sort of curriculum at that point, of course, because it was just sort of coming to be. But I'm wondering, given the magnitude of what this AI, the level of, and how fast it may accelerate, like should we be really wrapping our heads around this collectively, um uh you know as scientists and engineers and what have you, so that we can harness it and leverage it the right way, and also not the wrong way, right?
So
There's that.
should we be uh, considering ethical? Should we be looking at ethical considerations? Is that what you're getting?
Well,
Like
there's
how to use that? How do you when you say how to use it correctly? Certainly, what are ethical ways of using it? Or
yeah.
what are the implications of using the technology? And certainly, we've seen that our discipline, if I want to say computing in general, our discipline has a history of sort of building things they can build before thinking about what the consequences of that might be.
Sure,
Um,
sure. Yeah.
and I'm not, people would be like social media and all that. Well, certainly, if I had an idea, it's like, hey, I'll build some software where people can get in touch with each other and converse. It's like, this is a great idea, but then you see what it becomes.
Sure.
Um, Even years ago, the there were transitions like this. Not maybe not at this magnitude, but transitions that maybe weren't thought through carefully. And I'm not a Luddite here. I'm not like we shouldn't use technology, but maybe it'd be a good idea for us to consider things like, for example, when companies went from having records on paper to having records in a computer, what a great idea that was. Except that there were some people at the time that said, well, wait a minute now. If someone wants to steal the credit card records or our receipts for the last year, they have to go to a warehouse and they have to get a truck and they have to get
Right.
cases of boxes. And now it's like, okay, so now your entire sales records can be on a server that sits, it's the size of my file cabinet, a small file cabinet in my office, and someone from halfway across the world can access that. So there were implications of that that
Right.
that really people couldn't necessarily see, but it's turned out that now this has created issues that didn't exist before. Um,
Yes.
of course, it's
Yeah.
and I think that part of what you're talking about is, it's really difficult to know when you say, how should we use this? Maybe we should slow down, and I think maybe we should, but that's not, in my opinion, that's not likely to happen. We just have to hope that as we move forward, people are giving some consideration to what the technology might do, but realistically, I don't know that many people would foresee how it's used. We're humans. We're irrational beings in a lot of ways, and we're going to find out how this stuff is used, and hopefully we can deal with that effectively when we do.
Well, I think, certainly from the security and privacy perspective, um, companies like right now there are these companies like OpenAI, which was supposed to be open source and then it became, for profit. And then
Yes.
there's that story, and then Microsoft, I guess. So, but there's these companies like that own this technology, and people are uploading, or companies are going to be uploading information to their servers that could be proprietary information or very, you know, it could, and if it's people, it might be private information or personal information, and we don't have any idea how that's being stored, how that's being used. Is what I upload, or anybody uploads to OpenAI or these servers that's proprietary? Is Are there GPT engines using that to train such that if someone asks a question, it's going to like generate something that contains some proprietary information or personal information? It's possible, right? So
Yep.
so this is where I think, like, maybe the democratization or the much like there was big server centers pre-personal computing era,
Mhm.
should we really be, are we going to see some innovations in personal GPT computers and things, such that for companies and for people, such that you can have this stuff hosted in your own environment, knowing that it's not, on some server somewhere where it could be potentially exploited by that company or some hacker, right? And that maybe that might be an interesting trend or innovation that industry has to go into, versus just keep on throwing your personal and proprietary information on these servers, and and Lord knows if it's being used to train the network such that other people, you know, inadvertently get access to your information in some sort of roundabout way.
Oh yeah. So this is, security. This is an active area of research. How can we? What do they expose?
Yeah.
What do models expose about the data that's been using? There's a whole area that I'm not near expert on, differential privacy, and folks who work in differential privacy, they consider questions like this. Um, you want to get, as an example, I want to be able to look at medical databases and learn from them, learn what the best treatments are for certain things, learn how to distinguish or how to detect certain diseases early. At the same time, I need to get this information and use it in a way that doesn't expose any individual or doesn't identify, Paul's got this condition or Doug has this condition. This is a hard problem. This, but I think that so the other there are a couple of ways of looking at it. One of them is, can we do this in a way that doesn't give away Paul's information? And the other one is, oh, you know what, whatever you send it, whatever you do online is going to be, it's a bunch of people are going to be see it. So you just have to accept that. So it's like email. When I, email, that was that thing people used before, like Facebook and messaging apps.
Yeah.
Email. I tell my students, when you send an email, you should consider it a postcard. Like you're sending a postcard. Whatever you sent in that email, lots of people are going to be able to see. It's not secure at
Right.
all. So so but people still use email. You just don't put in, here's my bank account number and here's this, unless you're dealing with, the scammers or whatever.
Right.
Um, but which we know about a little bit. But so I don't know how this is going to play out. And I'm not sure, it's this from a security person perspective. There's always this tension between being functional and being secure, and so maybe in the future we're going to have to accept that some of our data is going to be exploitable, if we want to do the things that we want to do. So your notion of a private chat GPT, module that you use, okay, will it be as accurate when it's not learning from all these other users?
Right. Well, there's that. Yeah.
I mean, I'm not saying it won't. I'm just saying my guess is it wouldn't be. Um, Not to mention, I'm not sure, you know, I guess if you're hosting it on your computer, how do they make their money if you're, maybe you pay for it and then you pay a subscription or something. I'm always like, how do they make their money? Because, when Google started, it was like, well, they're a search engine. If they're not charging anyone, how are they making their money?
Right.
Well, now we know how they make their money.
Yeah.
So
No, it's true. Yeah. No, I know. I mean, there's that, right? And yes, it would have to be in some way still connected to the internet for it to be useful. It can't be completely isolated because it has to learn. But maybe for your private data, that maybe it's like a diode, right? You have information coming in, but your information doesn't go out. You know.
it could be.
Yeah. Anyway.
It's these are, we've reached the point where, in technology, do you really know everything that goes on in your computer? Right?
Oh, I'm sure I don't. I'm sure we don't. No.
Yeah.
Yeah. I mean, there's all kinds of processes and things like that spyware, malware, who knows what's going
What
on. But
information is being sent? And I'm not talking about someone sniffing the network. I'm talking about what information is going to a server when
right.
you access certain things. When you use ChatGPT, does it know that it's your request for this, or does it just know that it's a request for this?
Right.
Um, I don't have answers to that. I do know that things like ChatGPT, things like the internet, that little thing called the internet, are, these are big attack surfaces that some groups will want to exploit. And one thing that has changed over the years is that it's not a 12-year-old kid running a script that he found or she found. They're well-funded, talented, well-educated, um, organizations who are looking to exploit this. And so, from a security
Yeah.
standpoint, we have to be aware of. You mentioned the highways that assist in the autonomous vehicles. Yeah, this is just going to be another thing that is going to add to things that we have to secure. Um, that's unfortunate, but that's a reality, right?
Well, this is fascinating, and it's been fascinating. And I just have one more question.
I worry about this. Yes, given
Uh,
our history, I've.
now,
Hmm?
yeah. Oh well, now I have to think about it. No. Actually, it's more philosophical. Like because you're what you've studied, from math to computer science and chairing this department. If you could give Dougie Zaza your actual name, Dougie Zaza,
Yeah, my actual name.
if
Yeah.
if if the if the if you could advise the 20 5-year-old Dougie Zaza today what to study, what to focus energy on, who's interested in sort of AI and robotics and autonomy? Should they be looking at mechanical or electrical or software problems? Like, what would your sort of prescribed curriculum, so to speak, be a 4-year, 5-year sort of learning plan if they just really want to get into this and really boost themselves into the next era of technology that's at our doorstep? What would you sort of recommend they study in sort of general and maybe even more specifically?
So, wow, that's a great question. Um, so I would say that, I'm assuming that they're interested in doing this kind of stuff as opposed to, so this isn't a philosophical, like what I would tell my son, you must study software. It's, do what you like. But in terms of assuming that they want to be in this sphere, certainly don't shy away from the math. Um, I, and I'm not saying this because, I was a mathematician years ago. And I'm just saying that if you don't understand some of the math that's going on, you're not really understanding these systems well. I would say that you do have to start with machine learning. Learn about neural networks, learn about these architectures, um, learn as well how to make them. So I mean, not from scratch, but there are tools out there. There's TensorFlow, there's PyTorch, there are various Python libraries. Study that kind of stuff and use that kind of stuff to build simple models. And you're going to put yourself in a great position. You also mentioned generative adversarial networks. There are a couple of good tutorials on that. And there are tutorials that include, for example, Python code or TensorFlow code to learn that. Learn that kind of stuff. That will make you, and this is not to train you to be a researcher necessarily. This is to train you to be someone who will have some skills that are going to be very marketable and that are going to allow you to adapt too. So I'm always, yes, I'm an academic, and sometimes there's the old saying, those who can do, those who can't teach. And I'll say, well, yeah, in CS, that's really not the case. And in fact, it's not the case in most disciplines. But rather than just understanding the theory of how it's done, get your hands dirty and build this stuff and play with this stuff. And because it's not like learning the guitar. Actually, it is like learning the guitar, right? If you come to class for 3 hours a week and someone says, this is how you play the guitar, and you say, that's great, and you go home, you're going to be a lousy guitar player. The best students and the best musicians are the people who take what they've been taught and then they start spending a lot of time just experimenting with it. So if you have the tools, if you learn, TensorFlow, if you learn PyTorch, if you understand Python in these packages, you can start playing with how I build models. If you understand the mathematics, you understand this is what a generative adversarial network is really doing. This is what's going on under the hood. You just position yourself really well for adapting to whatever it is that might come down the pike. Does this
Well,
make
that's awesome.
sense? Yeah.
Absolutely. No, that's awesome. That's beautiful. That's beautiful. Well, thank you, Dougie Zaza or Doug Szajda, whatever name you're going by these days.
Professor S is what they call me here.
Professor S. Oh,
yeah,
like
because
that.
They can't. Good. Yeah, it's just easy. It's Yeah.
Well, thanks. This has been great, Doug.
This has been fantastic. Yeah, I really enjoyed it.
This has been super informative, and just appreciate your time and appreciate you as always.
Thank you, Paul.
Let's keep up the conversation.
Yes, let's keep up the conversation. I look forward to seeing you in person sometime soon, and we'll get out and drink some lattes with our pinkies up.
Sounds great. I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.